have eyes, ears, and a voice.
Something big's happening downtown.
This machine will have eyes, ears, and a voice.
Welcome to Dreams Come True with Sophia J450. The J450 is one of the best designed model turbojet engines on the market today. The J450 weighs 3.6 pounds. It has maximum thrust of between 11 and 13 pounds. It has a maximum RPM of 123,000. Each component of a J450 has been designed and built to withstand stresses far greater than those met in normal operation, so giving the modeler many trouble-free hours of pleasure. Tooled on the latest high-quality machinery, each piece is individually inspected to ensure nothing is missing, and each new engine enjoys a high degree of reliability. Let's now explore the insides of a J450 and explain how it works. First of all, the air is forced into the bell mouth, passing through the compressor wheel and around the front frame into the combustion chamber where it is burnt. Then the air is forced through the rear diffuser and into the turbine wheel and is forced out of the tailpipe. As the turbine wheel rotates the turbine shaft, this then turns the compressor wheel, which again draws more air in, repeating the process. A second airflow runs around the outside of the engine, which cools the engine down on the outside. The driving force behind Sophia is the president, Hiroshi Hoya. Sophia are based in Tokyo and specialize in all kinds of precision engineering, particularly high-quality miniature components. It's 13 and a half years since Sophia Precision was established. When I first heard about making a miniature jet engine, I was immediately very interested in it. Our tooling facilities are adequate in size for making the miniature jet engine parts. I also applied the personal experiences I have gained in my 20-year career in engineering. I have expert engineers who have retired from IHI working with me, who also wanted to meet the challenge of making a miniature jet engine. The first member of Mr. Hoya's technical team is Mr. Yoshimasa Nishi. Formerly, he worked at the aircraft engine division of IHI Industries as a mechanical engineer. He has had over 30 years' experience in engineering and manufacturing jet engine parts, and now works as Mr. Hoya's assistant at Sophia. Next is Kuniyasu Yamanaka. He also worked for IHI, this time in the Research and Development Department, dealing with jet engines. Introduced to Sophia by Mr. Nishi, Mr. Yamanaka now advises on the design of engine parts and manufacturing processes. Masakatsu Matsuki formerly worked at the National Aerospace Laboratory, researching gas turbine engines. He was especially involved with the development of the FJR 710 turbofan engine. At present, he is a professor at the Nippon Institute of Technology. Also on Mr. Hoya's team is Mitsusaburo Kawasaki, another ex-employee of the aircraft division of IHI, where he studied many different types of jet aircraft engines. Mr. Hoya invited him to join his group in developing a miniature turbojet engine. Sophia used the latest tool-cutting machinery to ensure that each component is engineered to the highest standard. Larry Tudor, an experienced engineer, explains more.
The machine behind us is a CNC lathe made in Switzerland by Schublin Corporation. It is an ultra-precision machine used for making parts not at a high production rate, but more at a very ultra-precision rate where the part must be placed in one at a time and can hold tolerances higher than even most of your very fine CNC machines. And this is the way that Sophia Precision is holding the very high degree of standard that they're doing in their turbine engine. And this machine in front of us is a Mazak quick turn center. It also is a CNC lathe, but of a much heavier capacity. And it at present is being used to turn the castings that are used for the rear diffuser section, the rear guide vanes of the turbine. And right here we can see the part as you view it here mounted on the fixture. And this part is where the hot gases come from the turbine, are turned into the turbine wheel. It starts out as a casting, is machined in this direction, then turned around here and turned on this outside like this. And now let's watch a few of these fine machines work. The rear vane guide, where the turbine wheel runs and that the hot exhaust gases are taken and turned into the turbine wheel, are all turned on this Mazak quick turn center, which is a very powerful machine capable of turning the very hard, high quality steel needed to handle the temperature at the back of the turbine. And if we move over to the machine, you will actually see one of the parts being turned at this time. In the turning process, the machine is capable of moving this turret back and bringing the different tools needed in to cut the various shapes that it has to cut here at the back of the nozzle assembly.
Let's now look at a J450 mounted on a test bed. This is the bell mouth where the air enters the engine. The air passes into the compressor wheel housing. It then passes into the combustion chamber where the fuel is injected. Once it is ignited, it is forced through the turbine wheel and out the tailpipe at high speed to produce the forward thrust. Let's now take a look at the J450 components. This is the fuel block with the fuel line in it. On the top is the oil block with the oil line down to the oil tank. On the other side of the J450 is the pressure block, and this also has a line to the oil tank giving pressure to it. This is a T-fitting where the pressure gauge is plugged in to see the pressure of the compressor. This is the spark plug which is connected to power during the starting sequence. The whole engine is fitted to this test bench, which will allow the engine to move so that the thrust can be measured. This is the thermal element to measure the exhaust temperature. This fuel line is a metal tube, but in the model you'll find that a plastic tube will work better as it is flexible. This is a very important part. This is a fuel filter. This will make sure that no foreign bodies enter with the fuel, thus damaging the engine. This is where the starter air is connected to allow you to blow air into the engine when starting. It's very important to use the correct color-coded tubes when connecting up your J450. The red tube is used for the fuel line, which is connected into the red fuel block. The white tube is used for the oil line. This makes it easy to see the oil flowing. The green tube is used as the pressure line connected to the pressure block, and also the oil tank. When you receive your J450, you'll need to fit the various lines into it. Let's fit the oil line. First, undo the nuts like this. And you'll see a brass fitting which has a cone on one end. This cone will press onto the oil tube, and once the nut is replaced, it will make a firm connection which should not slide out. Push the oil line into the nut, making sure you push it in firmly, and then tighten up the nut. Hold the back nut with one spanner and tighten up the other nut against it. This nut should be fairly tight. 3 or 4 turns should be enough. Now, if you loosen the nut, you'll see that the brass fitting has pressed onto the tube, holding really tightly. Next thing is to fit the quick release fitting to the end of the oil line. Once you've broken the connection like this, the oil will be cut off, and once connected up again, oil can run through. You take the end of the quick release fitting and push it onto the end of the oil line. Once you feel it click, it has now made a good connection. To remove it, you pinch it on the black ring and pull, and it will come off. This is the pressure line to the oil tank passing through the T-fitting, also using a quick release connection so that you can connect a pressure gauge. This is for starting purposes so that you can monitor the engine. Now, let's take a look at a J450 fitted into a Fiber Classic Sabre. If we remove the carbon fiber engine cover, you can see the J450 mounted in the model. It's been mounted up the same way as on the test bench, with the oil connection at the top. It has been secured using the provided turbine mounts. One here, one on the other side, and also one on the underside of the engine. The pressure block is here, oil block here, and the fuel block here. The air starter is easily reached here. It's important to mount the engine in this way, which will enable you to access all areas with ease. The only part you can't reach in this particular model is the ignition spark plug, but this is not a problem. It's simple to wire up the spark plug to the front of the model, making it easily accessed. So, we have shown the proper installation of a J450 into a model. It's very important that the J450 has a good airflow from the front of the model. In this model, this is easy, but different designs may need ducting, which most model aircraft manufacturers can supply. The J450 is surrounded by this carbon fiber cover, which allows air to also pass through the outside of the engine, cooling it. Over the exhaust, you need a titanium tailpipe to protect the model from the exhaust temperature. A second pipe is placed over this, allowing air to flow between them. It's important for the outer tube to be longer than the inner tube, and also the gap around the inner tube has to be the same all the way around for the cooling to work well. If we remove the outer tube, you can see how we have achieved this by using these mounts on the inner tube. Let's now start up one of the J450 engines in Wolfgang Kluwer's MiG-29. First, the turbine has to be primed with oil. About 5 cc of oil will do. This is because when starting, it takes about 20 to 30 seconds before the pressure builds up, and the bearings need oil during this period. It's very important to make sure the oil line is now connected correctly, and we now check the fuel pump is working. This is done by switching on the power in the model. You can now pump some fuel through, making sure that it is collected and not pumped onto the ground. Once again, make sure that the fuel line has been correctly connected by giving it a little tug. That's a good fit. So just before we start up, one last check that all looks okay. If need be, check each connection once again. A little time now could prevent any problems in flight. Now check that the ignition box is correctly connected and blow a little air through the turbine. Check with your hand that there is no air leak with the connection. Now switch on the ignition box and we can start. First, we have air, ignition, and on with the fuel. Once the turbine ignites, you must make sure that you watch the pressure gauge. Now you can remove the ignition and also the air. Now check the pressure. Slowly run the turbine to full throttle, making sure that it doesn't exceed 1.3 bar. Now you can adjust the transmitter to the full throttle setting. Now, check the low throttle position being no lower than 0.3 bar. Once again, the transmitter will probably need to be adjusted. We have now got the engine running properly. When stopping the engine, increase the power a little, then switch off. We now need some air to cool the bearings down. Wolfgang's MiG-29 is a scratch-built airplane developed for twin OS-91 two-strokes, fitted with Ramtech ducted fan units. Wolfgang won the German Masters of Jet Models twice with this airplane. October '96, he changed from the Ramtechs to two Sophia Precision J450. The performance of this airplane increased dramatically. The airplane weighs 13.5 kilograms without fuel. Wingspan 1.8 meters. Length 2.25 meters. This airplane is the prototype for a Fiber Classics 1/6 scale all-composite kit. It will hopefully be flown at the World Masters in 1997. The airplane is a very stable flyer. You can see this in the very windy conditions of the flight in front of Mount Fuji. The incredible flying characteristics of this airplane convinced us to make an all-composite Fiber Classics kit based on this prototype. When refueling, you must make sure that there are no air bubbles left in the fuel bags. This is done by squeezing the air from the fuel pipe until all has gone. Be very careful not to squeeze too hard, or the fuel will squirt out of the top. Then block the end with the end cap and you're ready to fly. Let's now take a look at the transmitter as we go through another start. First, set the throttle stick to the starting position. The air is applied and also ignition. Once the engine ignites, bring the fuel back a little, and now slowly increase it again. Once the turbine is running fine, you can slowly increase the fuel to full throttle. If you need to adjust your transmitter, do this now. Then slowly pull back to low throttle, and here you may need to make some adjustment to your transmitter. To stop the engine, push the throttle to half power and then switch off. Saab Draken. This is also an airplane of Wolfgang Puhr. We use this airplane as a flying test bench. We've made many flights with this airplane equipped with the Sophia turbine. We developed the Fiber Classics installation kit, carbon ducting and titanium injector pipe, in this airplane for high-speed flights. The airplane has a speed of over 200 miles per hour at full throttle. The Draken is a very good flying airplane. Fiber Classics are thinking about doing it as a kit as well. The weight of this airplane is 8 kilograms without fuel. It has hundreds of successful flights on it. It's ideal for turbine because its wing and air intakes give a lot of space for fuel tanks exactly in the center of gravity. The real Draken is a Swedish jet. Its delta wing is responsible for a very characteristic silhouette.
スウェーデンのサーブドラケンですね。サーブドラケン。このサーブという会社は皆さん乗用車でもサーブというとあの車かと車マニアの方は思われるかもしれませんが。ボロランキング13点です。サーブリバース9番へと変わってスローロード。
Well, this is one way of mounting a J450 onto an aircraft. This seaplane makes an unusual subject for a turbojet installation. Or on a larger scale, this Japanese Airlines jet taking off with 2 J450 turbines. We're at the 1996 RC Air Pageant, held on a purpose-built airfield a short distance from Tokyo. With over 70,000 spectators watching, the 2 J450 turbines have no trouble in powering this large model through the air. Later on in the day, Wolfgang Kluwer flew the MiG again. A good steady climb away from the ground, showing off the power of the twin J450 power plant. The Sabre is a Fiber Classics kit. Its wingspan is 1.92 meters, 1/6 scale. Weight is 10 kilograms without fuel. The airframe is all composite. All surface details like rivets, panel lines, overlaps are molded in. Its silver gel coat doesn't need any paint, but you might want to apply some decals. This airplane has scale retracts, flaps, working leading edge slats, pneumatic-operated speed brake doors and wheel brakes, as well as a pneumatic-operated sliding canopy. This airplane seems to be made for the Sophia jet engine. It matches perfectly. The takeoff power is just right. In flight, I can throttle to 60 to 70% for scale flight. A lot of difficulties were with the prototype because we had no experience with turbine power. The knowledge we gained with this airplane, particularly with installing the J450, has been incorporated into the Fiber Classics kits. Our experience with the Sophia turbines led to our development of a microprocessor turbine controller to simplify the handling of the J450. This unit works basically as an FET controller, but is controlled by RPM and temperature measurements. The whole unit is smaller than a cigarette box and fully programmable. When you see the video of the starting procedures, you'll realize that it's still possible to make a mistake. You must know a lot about turbines to understand everything that's going on. This controller unit automates the whole procedure. It's called Automatic Startup Sequence. This allows you to control the startup procedure with only the air trigger. If you press the air starter, the ignition and the fuel pump will start automatically. The engine ignites automatically, ramps up to 80,000 RPM, and switches over to transmitter control when everything is okay. The ECU will halt the engine startup if any problems appear. The ECU will not allow hot starting, low RPM overspeeding. Everything is exactly controlled. This controller will be standard for the 1997 production and can now be retrofitted to any J450 purchased before 1997. Wolfgang, we saw just now your fantastic MiG-29, which you equipped with two J450 just a few weeks ago. It was equipped with Ramtech fans before. What is the general difference?
Actually, there are two main differences. Firstly, there is the delay in throttle response, in this case about 3 to 4 seconds between idle and full throttle. And secondly, the performance is much improved. That means definitely more power, but also more weight, which is more of an advantage than a disadvantage, as it helps make the aeroplane more stable in flight.
Some people say that it's dangerous to fly with turbines. What's your experience?
Es kann gefährlich werden, wenn ich keinen Feuerlöscher zur Hand habe.
Yes, it might become dangerous if I didn't have a fire extinguisher close by. Problems always seem more likely to happen when something's not there when you need it. Turbines have to be handled with care. I'm not afraid of them, but I do treat them with respect. It's a high-tech machine, and everybody should remember that.
Ein hochtechnisches Gerät und so muss es auch behandelt werden.
We know that you're a jet expert, but 2 turbines in a model is really a high effort, technically and also financially. But you got it very quickly and didn't have any big problems. So it doesn't look too difficult, does it?
Nee, es ist auch nicht schwierig.
No, that's true. It's not too difficult. But you have to take care of many things. It's very important to make a checklist, which helps you not to forget to fill the oil, connect all the tubing, things like that. As long as you are thorough, then really it's not very difficult.
Would you like to change back to ducted fan?
No, never, not at all, and definitely never this model.
In your own words, what is turbine flying for you?
Als wenn Engel schieben.
It's as if angels are pushing. Thank you.
So, once you've purchased your J450, how will it be possible to get it serviced without sending it back to Japan? Here is Larry Tudor again.
Well, as you can see by the degree of the machinery here at the factory, the servicing is something that cannot be accomplished by someone in their home. It requires some special tooling, some very high precision instruments to align the reassembly of the turbine, and I am very happy to say that I have been brought here to Sophia to learn these proper processes so that I can be the service agent in the United States and Canada, and that there are many agents around the world that will be trained to service your Sophia turbine in the proper way so that it is not necessary to send it back to Japan if you have a problem, and that your engine can be fixed in your home area and gotten back to you very quickly so that you can get back in the air again.
Sophia Precision would like to thank you for watching this video. And if you'd like any more information about the J450, then please don't hesitate to contact us at the address that is on screen now.